Last chapter of section 2, electromagnetic waves and communication system. Getting right? Electromagnetic waves and communication system. Electromagnetic waves and communication system. Electromagnetic waves and communication system. Simple chapter. Some of you might have studied chapter called spectrum in 10th standard. So partly it is that, and then second part is communication system. So suppose we have to communicate, then we require three things. एक बोलने वाला, एक सुनने वाला, और बीच में मीडियम इसका आवाज लेके जाने वाला. So something which is transmitting from one place to another, we say it is getting communicated or moved. So to communicate, electronic signals such as TV signal, video signal from one place to another, we require some medium, and through that medium something should travel. That's something, that means suppose I'm speaking here and voice is reaching to your ears, that means my voice is getting converted into some signal through that microphone. So those signals are electromagnetic wave. How it is created, I will explain. So whenever we are doing communication, we require three things. One, who will emit, usko bolte actually transmitter. Second, who will collect, that is called as receiver. And this is channel through which it is going. This thing forms communication system. And through this channel, electromagnetic wave will travel, which is containing the information such as audio, video, signals. So now what are electromagnetic waves? And then we'll see how it is helpful in communication system. See, suppose this is charge. What it will give in the vicinity if this is charge, charge, charge. What it produces in the vicinity, in this surrounding, what it gives? Electric field. So space surrounding charge, we know it is called electric field. What is moving charge called as? Charge moves. What that quantity called as?
Current.
Current, correct. So moving charge is current. If it is stationary, it will give electric field. If it is moving, it produces current, and whenever current moves, we get magnetic field also.
Yes, sir.
Yes, sir.
So that means if I have charge which is oscillating, moving up, down, up, down, up, down, up, down, तो आजू बाजू में क्या प्रोड्यूस करेगा? इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड, इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड, बार बार प्रोड्यूस करेगा ऐसा?
Yes, sir.
Yes, sir.
So this electric and magnetic field, they are perpendicular to each other. So when charge is oscillating in a medium, they produce electric and magnetic field. From electric and magnetic field, invisible waves are produced. That means disturbance. Those disturbance traveling perpendicular to both electric and magnetic field. That means along z-axis, like transverse wave, are called as electromagnetic wave. Electro means electric, magnetic means magnetism, wave is disturbance. So in exam they can ask, what are electromagnetic waves? State the characteristics of electromagnetic wave. So first, what are electromagnetic waves? See, if this is electric charge, then field will be this way. Current is moving, then it is right hand thumb rule say perpendicular, correct? By right hand thumb rule, if you have done in 10th, imagine current, conductor to be held by right hand and curled thumb in the direction of current, then curled finger represents magnetic field.
Yes, sir.
So at this point, if I want magnetic field, then it will be tangential to the surface. And electric field from charge, you know that it starts perpendicular to the field, to the surface. That is property of line of force. So one is tangential, other is perpendicular. They are perpendicular to each other. So that's why we assume that electric and magnetic field are perpendicular to each other and produces disturbance, which are called as electromagnetic waves. Now it will be electromagnetic wave only if the charge is not constant but oscillating. Because if this is, suppose, imagine these are particles of the medium. From here one disturbance comes. So it will lift this particle, and it will oscillate till its entire energy vanishes. ये बाजू वाले को भी लिफ्ट करेगा थोड़ा फोर्स से, इलेक्ट्रोमैग्नेटिक फोर्स लिफ्ट करेगा, इसको जस्ट डिस्टर्बेंस मिलेगा. So this way 1/4 wave gets created. After it loses entire energy and comes to rest, then it falls downwards and reaches here, this disturbance. By that time, fourth wala will reach to the top, lifting other particles. So we get half wave. At mean position here, by falling, velocity becomes maximum. So it will go downward till entire energy again becomes zero. And fourth particle will come again at mean. Suppose seventh particle is lifted upward. So this way 3/4 waves are formed. Again when 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again this one when goes up, 4 will come down, 8 will come to the mean, lifting the other particle. So this way we get one wave. That means when particle completes one vibration, up, down, down, again up, then it sends one wave in the medium. So to do this, the charge should oscillate. That's why oscillating charges produces electromagnetic wave. Now I'm dictating the definition. What are electromagnetic waves? Right. The waves that are produced by the waves that are produced by accelerating charged particles consists of the waves that are produced by accelerating charged particles consists of charged particle consisting of electric and magnetic fields vibrating sinusoidally perpendicular to each other. Sinusoidally perpendicular to each other and perpendicular to each other and to the direction of propagation are called as electromagnetic. In short form, we can write EM waves or electromagnetic radiation. So in exam fixed question, what are electromagnetic waves? The waves produced by accelerating charged particle consisting of electric magnetic field vibrating simultaneously perpendicular to each other and to the direction of propagation are called as electromagnetic wave or electromagnetic radiations. Yes, done now?
Done, sir.
Done, sir.
So electric field and magnetic field are perpendicular to each other and also to the direction of propagation of wave. So representation of electromagnetic waves. Y, X, Z. Electric vectors, that means vibration of the charge, is taken along y-axis. So this is vibration producing electric field which is along y-axis and perpendicular to x. Similarly, magnetic field is taken to be vibrating along z-axis vibration is along z-axis. This is also perpendicular to x. So this is representation of electromagnetic wave which has got electric vector E bar along y-axis, magnetic induction B bar along z, and propagation along x. Draw diagram. See, electric vector is fixed along y. You can take magnetic along x and y, propagation along z. So this naming we can change. But E and B are perpendicular to each other, that you cannot change. E is along y, this you cannot change. So I have shown electromagnetic wave traveling along x-axis with E bar along y and B bar along z. Once you complete the diagram, tell me. This is again one of the easiest chapter. Is completed?
Yes, sir.
Okay. So we studied what are electromagnetic wave. They are waves produced by accelerating charge consisting of electric and magnetic field perpendicular to each other and to the direction of propagation are called as electromagnetic wave or electromagnetic radiation. It is represented by electric vector vibrating along y and magnetic along z, propagation along x. So x, y, z, they are mutually perpendicular to each other. Next slide. Characteristics of electromagnetic wave. Characteristics of electromagnetic waves. See, no derivation in the chapter, all theory is there. Characteristics of electromagnetic waves. First point. If vibration is perpendicular to the direction of propagation, then what is this wave called? Where vibration is perpendicular to the direction. What is that wave called?
Transverse wave.
Transverse wave, correct. So can I say electric and magnetic field are perpendicular to each other and to the direction of propagation. Hence electromagnetic waves are transverse in nature. First point. The electric and magnetic field and magnetic field denoted by E bar and B bar are perpendicular to each other and direction of propagation, perpendicular to each other and to the direction of propagation of the electromagnetic waves. Hence, the EM waves are transverse in nature. Hence, EM waves are transverse in nature. Shall I clear it off now?
Yes, sir.
Okay. What is direction of A bar cross B bar? Direction of A bar cross B bar?
Perpendicular to A bar and B bar.
Perpendicular to both A bar and B bar. So if A bar is along y-axis and B bar is along z-axis, where will be this A bar cross B bar? Can I say along x-axis?
Yes, sir.
Yes, sir.
So if this is E bar, electric field, this is B bar, magnetic field, then their cross product represents the direction of propagation, that is x-axis.
Yes, sir.
Okay, second point then. The cross product E bar cross B bar gives the direction, the cross product E bar cross B bar gives the direction in which electromagnetic waves travels. It is also the direction in which energy is transferred. It is also the direction in which energy is transferred. Second point done.
Done, sir.
Okay, third point. You have to remember four because this is guarantee question. What are electromagnetic wave and its characteristics? Third point. The E bar, that means electric field, and B bar, that means magnetic field. E bar and B bar vary sinusoidally. Sinusoidally means their equation will be of the type something sine angle. That means B will be B naught sine and E will be E naught sine. That is meaning of they will change themselves like sine function. So E bar and B bar vary sinusoidally. Now once again I will explain what is meaning of sinusoidal. See, suppose E is E0 sine theta. When theta is 0, then sine 0 will become 0, correct? No?
Yes, sir.
So
Yes, sir.
this is that particle then, or that electric field ka start. When this is 90, sine 91, this will be that maximum position, E naught. Again when 180 it becomes 0. 270 it will become negative, 360 0. So this is the nature of that wave, which is called sinusoidal. So E bar and V bar vary sinusoidally and are in phase, मतलब साथ साथ में vary होता है. E bar and V bar vary sinusoidally and are in phase. In phase मतलब दोनों एक साथ ऊपर जाएगा, एक साथ नीचे आएगा. Amplitude may be different. That is called in phase. Fourth point. In phase का भी वापस देख लो. This is one wave traveling. इसके साथ इधर से दूसरा वेव स्टार्ट हो गया. Then we say they are in phase. मतलब एक साथ. But one wave is here. दूसरा इधर से चालू हो गया. तो ये सेकंड वाला पॉजिटिव वाइब पे है, इसको बोलते हैं लीडिंग. इफ एक वेव इधर से स्टार्ट हुआ, दूसरा वाला इधर से, then we say second is lagging. So these are three different modes we will study in 12th standard under heading oscillation. So you all are simultaneously studying, simultaneously moving, writing the test. So we say you all are in phase. But your friends, those who are in 12th, they are leading. Other friends, those who are in 10th, they are lagging. So E and B are not lagging, leading, they are together. साथ में electric magnetic field ऊपर नीचे vibrate होएगा. So in phase with each other. Third point. Fourth, electromagnetic waves are produced by accelerated charged particle. This is mostly asked in MCQ. Electromagnetic waves are produced by dash. It is produced by accelerated electric charges. So first they were perpendicular to the direction of propagation. Second we wrote E and M ka cross product, E and B ka will give direction. Third, they are in phase and sinusoidal. Fourth, it is produced by accelerated electric charge. Electromagnetic waves can travel through vacuum or solids, comma liquids, comma gases. They can travel through solid, liquid, gases and also through vacuum. Copy 5 points. Mostly this MCQ questions theoretical will be based on characteristics. Yes, completed first 5 points.
Done, sir.
Okay. Sixth. Very important point. Sixth one. In free space, electromagnetic wave travels with velocity c in free space. Electromagnetic wave travels with velocity c equal to the velocity of light in free space. That means it travels with the speed of light. It is given, एक मिनट और इजी कर देता हूँ थोड़ा वर्ड्स. In free space, electromagnetic waves travels with the speed of light in free space. That is c equals to 3 into 10 raised to 8 meter per second. It is also given by c equals to 1 upon root of mu naught into epsilon naught. See, mu naught is constant used in magnetism called as permeability. Epsilon naught is called permittivity. Right? 6 point. So in measurement chapter, they may ask you what is dimension of mu naught and epsilon naught together. Remember, it is nothing but c equals to 1 upon root of mu naught and epsilon naught. So if you know c ka dimension, you will get epsilon naught and mu naught ka dimension very easy. Next lecture, this chapter will get over. That means Tuesday we are completing second part of physics. I think thermal properties completed or going on?
It's still going on, sir.
Okay, so when that is no, sound is left out. 6 point done.
Yes, sir.
So in free space, it is 3 into 10 raised to 8, which is 1 upon root of mu naught epsilon naught, 7th. In a given material, in a given material, the velocity V means velocity, M means in a medium, of electromagnetic waves is given by Vm is 1 upon root of mu epsilon. That means permeability of medium to that of permeability and permittivity, where mu equals to permeability of medium, not free space now, medium, and epsilon is equals to permittivity of medium. Right, seventh point also. If it is free space, then you will get mu naught epsilon naught, in medium mu epsilon. So 7th point also done.
Yes, sir.
Okay. 8th point. Since these are waves, that means they will add, subtract. That addition subtraction is called superposition. So we say the electromagnetic waves obey the principle of superposition, meaning I'm explaining what it is. Suppose this is one wave traveling and this is another wave traveling. Crest when meets with crest, resultant will be crest of larger amplitude. Trough of larger. That means they can be added, subtracted by vector method. That is called principle of superposition. Or simple में बोलूं तो suppose this is one point, one wave comes and disturbs that particle, it starts oscillating. Second comes, it helps this vibration depending upon its nature. So when two or more than two wave arrives at a point simultaneously, then each wave produces its own displacement as if other waves are absent, and the resultant displacement is vector sum of displacement produced by each wave. This is known as principle of superposition. एकदम layman language में अगर बताऊं तो, suppose these are 3 classrooms. In all, lecture has to be started at 7. 3 teachers simultaneously they entered in 3 different classrooms. Will it happen that first wala teacher will say 7 to 7:30 I will deliver the lecture, you people please don't disturb me. Second says then 7:30 मेरा नंबर आएगा, आप लोग कुछ मत डिस्टर्ब करना. थर्ड वाला बोला मेरा नंबर फिर 8 to 8:30 आएगा, you all don't disturb. Will this happen कि all will start disturbing the students simultaneously as if neighbors are absent? अगर दोनों का आवाज जोर जोर से साउंड प्रूफ नहीं है बीच में, तो ये आवाज जॉइंट होके स्टूडेंट को इधर समझ में नहीं आएगा ना क्या चालू है. अगर दोनों जगह पे फिजिक्स है तो उसको लगेगा फिजिक्स का कुछ तो चालू है. एक फिजिक्स एक बायो तो कॉकटेल हो जाएगा ना, समझेगा नहीं. मतलब क्रेस्ट मिलेगा, बड़ा क्रेस्ट आएगा, क्रेस्ट और ट्रफ मिलेगा, कुछ नहीं आएगा, कैंसिल हो जाएगा. So this addition subtraction by vector method is called as principle of superposition. 8 point clear?
Yes, sir.
Okay, write 8 point. Electromagnetic wave obeys the principle of superposition. That means resultant is vector sum. Nine. Sixth point. The ratio of amplitude of electric and magnetic field is constant. The ratio of magnitude of electric and magnetic field is constant at any point and is equal to the velocity of electromagnetic waves. Important, I said, because mostly numerical, they can ask you based on this. Now examples.
Sir, wait.
Okay, right. Then I'm rubbing and writing the example. Right. Important points means MCQ of numerical can be created. एक बार JEE में पूछा है इसको. Completed?
Done, sir.
Okay. So ratio of amplitude of electric and magnetic field is constant at any point and is equal to velocity of electromagnetic wave. See what does it mean? since E is E naught, that means it is sinusoidal function, sine omega t, and B is B naught, sine omega t, then this is called amplitude of electric and this is called amplitude of magnetic. So E naught upon B naught is equals to speed in air, which is nothing but 1 upon root of mu naught into epsilon naught. Now, how it comes like this? In next year, you are going to study electric force is QE and magnetic force is QVB. This we are going to study in 12th. When both becomes equal, then charges will get cancelled. So velocity is actually E upon B. E means electric field, B is magnetic field. So because of that, we say the magnitude or amplitude of electric and magnetic fields ratio gives the velocity. So write this formula write down in ninth only. If E is this, B is this, then E naught upon B naught is C, which is 1 upon root of mu naught into epsilon naught. Completed?
Done, sir.
Okay. Next one. 10th point. The electric field vector E bar, electric field vector E bar is more, here we are talking about its amplitude. So E naught bar is more prominent, मतलब इसका value is more, E वाले का prominent than magnetic field vector, because see E upon B velocity है and velocity is 3 into 10 raised to 8 in air, मतलब numerator is greater. So electric field vector is more prominent than magnetic field vector, which is B naught bar in magnitude and direction. So electric field which is more prominent than magnetic field, it is responsible for optical effect, because electric से light आ सकता है. So electric field is responsible for optical effect due to electromagnetic waves. So which field is responsible for optical effect? Electric field, because whenever there is electric, light भी आ सकता है. So it is responsible for electric effect due to electromagnetic wave. Hence, electric vector is called as light vector. So in 12th you are going to study this electric vector produces light waves in the medium. 10th point, right? Total 12 points are there. 10th we take, 2 more we'll do, then numerical we are going to do. And next lecture this chapter will get over. As I said, it is maximum theory. Yes, done. Hello, completed?
Yes, sir.
Okay.
Done, sir.
Fine. 11th point. This is for numerical importance. The intensity of wave is proportional. The intensity of wave is proportional to the square of its amplitude and is given by intensity due to electric is half of epsilon naught into electric field square. See, this we are going to study in again 12th standard, how that intensity is half epsilon naught E square, and due to magnetic field both derivations are there in 12th, is half of B naught square upon mu naught, half epsilon naught E naught square. This is half E का जगह पे B आया, epsilon naught 1 upon mu naught हो जाता है. We'll study in 12th. This is in chapter called magnetic field. In fact, in chapter called electro AC circuit, and this is in electrostatic. Write this formula. Intensity is proportional to amplitude and given by half epsilon naught E naught square, and magnetic wala I means intensity here, E is electric field. I means intensity, B is magnetic field. Write this too. Directly they can ask in JEE, find the intensity if the equation is given. So from equation you can get E naught, epsilon naught is constant. Completed this also?
Yes.
Okay. Last point. 12th one. The energy of electromagnetic wave. The energy of electromagnetic wave is distributed equally between electric and magnetic fields. Therefore, intensity of electric field is same as that of magnetic field. 12th point. Okay, done.
Yes, sir.
We are doing now numericals based on this theory. First numerical. Calculate the velocity of electromagnetic waves in vacuum. Calculate the velocity of electromagnetic wave in vacuum. What is formula for the velocity of electromagnetic wave in vacuum? If E and B given, then that ratio. Or we can say velocity in vacuum is 1 upon root of mu naught into epsilon naught, because this values we are knowing. So this is nothing but 1 upon root of mu naught is 4 pi into 10 raised to minus 7. You have to remember. Permittivity is 8.85 into 10 raised to minus 12. You have to remember. So this will become then 1 upon root of 4 into 8.85 will become 4 into 5, 20, 4 8s are 32, and remainder 3. 4 into 5, 20, 32, and 2, 34. 4 8s are again 32, and 3 is 35 after 2-digit decimal into pi 3.14 into 10 raised to minus 8.85 into 10 raised to 12. 12 and minus and minus 12 minus 19. So this I can write as 1 upon root of 35.40. This is minus 19. It cannot come outside. It should be multiple of 2, 4, 6, 8. So I'm making it 10 raised to minus 20. तो 31.4 कर लेता हूँ इधर और इसको minus 20 कर देता हूँ. That means I have multiplied by 10 divided by 10. So that will become root of 35.40 into 31.4. 10 raised to minus 20 comes out, minus 10, it goes up, 10 raised to plus 10. Please copy this much. completed?
Yes, sir.
Done, sir.
So when you simplify that square root with 10 raised to 10, final answer will come 3 into 10 raised to 8. That is equals to 3 into 10 raised to 8 meter per second. Now second sum we are doing. Hello? अब भारतीय एयरटेल का 610 वाला कॉल नहीं, अपन निकाल दिया भाई। ये पहले करते हैं, देखते हैं। हाँ, बैंक निफ्टी क्या है, मतलब लेने के लिए क्या करंट का 610 वो कुछ 8 में रखना। हाँ नहीं, कम हुआ था अभी 610 का 8 में रखना, 8 में। आप क्या बोल रहे थे स्ट्रेटेजी का? हाँ, आपने एक बार बताया था मुझे शायद, तो मैं अपना आपको, हाँ नहीं चलेगा, मैं आपको एक आधे घंटे में करता हूँ, फिर अपन बात करते हैं उसको। ठीक है, नो प्रॉब्लम, नो प्रॉब्लम। हेलो पीयूष, हेलो। पंजाब नेशनल बैंक का 43 का क्या चल रहा है? हाँ करंट उसको अपन 90 में रख सकते हैं, 90 पैसे। हाँ अच्छा, ठीक है। SBI का पीयूष और हाँ चलो कितना है, वो 430 देखते हैं, उसको 10 में रखना नहीं चलेगा, 420 10 में रखना। ठीक है, ठीक, नो प्रॉब्लम। Next sum. Electromagnetic wave velocity in vacuum or free space will be always 3 into 10 raised to 8. Second one. In free space, an electromagnetic wave of frequency 28 megahertz. 28, capital M means mega, small m is milli. Mega means 10 raised to 6, milli is 10 raised to -3. Travels along the x direction. The amplitude of electric field is E equals to 9.6 volt per meter, and its direction is along y axis. What is amplitude and direction of magnetic field P? Please write the question. Very, very important for entrance. In free space, an electromagnetic wave of frequency 20 megahertz travels along x direction. The electric field is along y, so guaranteedly magnetic field should be z. Then only x, y, z are mutually perpendicular. Yes, written question. We want magnitude and direction of electric field. Written a question written.
Yes, sir.
What is relation between E, B and velocity? Because E is given and velocity ka value we know in free space. So can I say since C is E upon B, so B can be written as E upon C. E is given 9.6 and this C is 3 into 10 raised to 8. Therefore, we get 3 into 2, 3 3s are 9, 3 2s are 6 into 10 raised to minus 8. 3.2 into 10 raised to minus 8 unit is called Tesla or Weber per meter square. So we got magnitude. Now since electromagnetic wave is along x and E along y, hence B must be along z. So we got magnitude 3.2 into 10 raised to minus 8 and direction is along z axis. Now copy full. Okay, done.
Yes, sir.
Done, sir.
Okay, next one. Good. A beam of red light. A beam of red light has an amplitude 2.5 times amplitude of second beam of same color. Second beam of same color. A beam of red light has amplitude 2.5 times amplitude of second beam of same color. Calculate the ratio of intensities. Ratio of intensities of two waves. So one wave amplitude is 2.5 other, then find what is intensity. Now we know that intensity is equals to square of amplitude. Red light has amplitude 2.5 times amplitude of second wave. So A1 is 2.5 times second wave, that is A2. So I1 upon I2 is A1 upon A2 square. Therefore, I1 upon I2 is 2.5 times A2 upon A2 square. Therefore, I1 upon I2 2.5 square is 6.25. So answer, ratio of intensity is 6.25. Sorry. Okay, done.
Yes.
Next one. State the formula for electric and magnetic field in electromagnetic waves. So not prove, it is just state the formula for electric and magnetic field in electromagnetic wave. The electric and magnetic fields are perpendicular to each other and to the direction of propagation of wave. Thus, it is represented as E is along y-axis and B we have taken along z-axis. So you are going to study in chapter, I think, sound wave also. There will be something of oscillation, and in 12th in detail everything of oscillation. So this is denoted by E naught. Here B naught sine. This is actually formula of simple harmonic progressive wave, which you are going to study in chapter called sound, given by kx minus omega t. This will be same in phase, so same angle. Kx minus omega t. So formula for electric field is E naught sine kx minus omega t. Magnetic field Bz equals to B naught into sine kx minus omega. Just write this formula. Write theory full. Okay, done.
Yes, sir.
2-3 more lines you have to write regarding what is E naught and B naught. E naught is amplitude of electric field E y, and B naught is amplitude of magnetic field Bz. 2 pi by lambda 2 pi by lambda is called as k, which is this all you are going to study in chapter called sound. So 2 pi by lambda is that k connotation is called as propagation constant. Propagation constant, and lambda is wavelength. So k is 2 pi by lambda called as propagation constant. Just write this much. One numerical will do, then we'll stop. Next class we'll do what are electromagnetic spectrum and then communication system. Done?
Yes, sir.
Okay. One small sum, then we'll stop. See, this is theory. Please study today only all the theory. Next sum number 4. An electromagnetic wave of frequency 50 megahertz travels in vacuum along the positive x-axis. So along the positive x-axis, E bar at particular point x and at a particular instant t is 9.6 j cap. J cap means it is along y axis. Volt per meter is its unit. Find the magnitude and direction. Find the magnitude and direction of V bar at this point x and at instant of time t. Same as one sum which we did, similar to that. An electromagnetic wave of frequency 50 megahertz travels in vacuum along positive x-axis. E bar at particular point x is given by 9.6 along y-axis. Find magnitude and direction of V bar at this point and at instant of time t. Okay, can I clear this now?
Yes, sir.
Okay.
Wait, sir.
Okay. Wait. Okay. Waiting.
Done, sir.
Okay. Very simple sum. Whenever E given and B they ask, remember that C is nothing but E upon B. So B will become E upon C. E is 9.6 in magnitude. C is 3 into 10 raised to 8. So that is 3.2 into 10 raised to minus 8. Unit is Tesla. Therefore, and its direction is perpendicular to both x and y. So its direction is along z-axis. So therefore we can say B bar will be in magnitude 3.2 into 10 raised to minus 8 K cap. That many Tesla. Copy this. (3.2 into 10 raised to minus 8 K cap Tesla. Done? So
Done, sir.
yes. Today we stop here. Next class we'll continue this. Tomorrow test is on measurement and scale.